All right, letter E, a yield sign, equilateral triangle. Draw a yield sign on the coordinate plane using the origin as a vertex. For an equilateral triangle, it's just going to be one of the corner points of my triangle. If the length of one side is m units, find the coordinates of the other vertices in terms of m. All right, so this is what the equilateral triangle is basically going to look like. Now, again, I can't put these in exact positions because I don't know where the square root of 3 times m over 2 is, but I'm going to do my best to place things so it looks like an equilateral triangle. Now, where did these points come from? Well, this one's the easy one. If I know that the side lengths are m, then the side length along the x-axis is going to be at m, because it goes m units across the x-axis, and then 0. So that's the benefit of having one of my sides along the x-axis. But what about the third coordinate? I need to figure out the x and the y for this third coordinate. X is easy. Because it's an equilateral triangle and one of my base sides is along the x-axis, that means that the top side is going to be halfway between. So that's just, if this is m, then the x coordinate for this point is m over 2. The third point is really tough to figure out and takes some thinking, and sometimes they do. So sometimes you're going to have to go through quite a few steps to get what the third point is going to be in something like this. Let's think about this for a second. Here I have a right triangle with sides m over 2. This is the side I'm looking for, y. And here's the hypotenuse. Now, the hypotenuse of this has to be m because all side lengths of an equilateral triangle are m. So m over 2, and then whatever this value is. This is the one I'm looking for. I need this because this is going to give me my y coordinate. Now, I know that a squared plus b squared equals c squared, but in this case, I'm not looking for the hypotenuse. I know the hypotenuse is m. So this is going to be c squared minus one of the legs squared. In this case, the leg we know is m over 2. So c squared minus m over 2 squared equals b squared. I'm going to replace that again. Now, we know this is length m, so it's going to be m squared, okay, minus m over 2 squared is going to give me this third side. I'm just going to call it y because it's the y coordinate, so y squared. All right, to simplify this, I'm going to square this entire second term. M over 2 squared becomes, and again, I put this in sort of a weird way. It's going to be 1/4 m squared, or really, I'm going to move this around and make it m squared over 4. That probably is a clearer way to write because I squared this and then I squared this. Okay, and it's still going to be minus because the squared does not apply to the minus outside the parentheses. Well, m squared minus m squared over 4 is going to be 3/4. So I'm multiplying 1/4 of m squared. I'm subtracting 1/4 of m squared from m squared. This is going to mean I have 3/4 of m squared left. So y squared equals 3/4 of m squared. Now I need to take the square root of both sides to get y by itself. That's going to be the square root of 3. I have to take the square root of everything on this side. The square root of 3 over 2 times m. And again, I'm going to take this m out here and put it where it makes more sense right there. And that is my y coordinate in terms of m. So that was a tricky one. Sometimes they are. So be ready for things like that. All right. Now, you see there's just a ton of writing on this page. I'm going to say this. A lot of times the problems from this unit are just going to ask for an answer developed from a coordinate proof, not for you to do all of this proving on your own. So that should be a little bit encouraging to you. Sometimes you still have to do a lot of work though. So I guess that's the balancing, discouraging thing. Sometimes you do have to do a lot of work, but you're ready for it. All right. Do the problem set 1 through 30 for next time.